Okay, so an example of the alternating series test. So let's see. Oh, very good one. Okay, so we have this n equal to 1 to infinity of negative 1 n minus 1 times 1 over n. Okay, so this right here is our Bn. Okay, so let's expand this really quickly. So if I put 1 in, that's going to be 0. So that means that this is going to be 1. Would you guys agree? Okay. Then the next one, if I put 2 in, that this is going to be to the first power, so that's going to be minus 1/2. Do you guys agree? Okay. So plus 1/3 minus 1/4 plus 1/5 minus 1/6 and so on and so forth. Okay. All right. So now let's look. Okay. Is this one, it's supposed to be less than or equal to this one, right? Question mark. Okay, so we can see, okay, well, I have 1/2, I have 1, then I have 1/2, and I have 1/3, and then I have 1/4, and I can see each one, this is starting to decrease. So therefore, this is B2, this is B1, this is B3, this is B4. This guy is smaller than this guy, and this guy is smaller than this guy, and this guy is smaller than this guy. Right? Would we agree? Yes, now we agree. All right. And so therefore, my first condition is met. Okay? So now my second condition. Does the limit as n goes to infinity of Bn equal to 0? Question mark. So let's do it. So if I take limit as n goes to infinity of 1 over n, this one's easy. When I put infinity in for my n, it is going to go to 0. So yes. So both conditions are satisfied. So in this situation then, n equal to 1 to infinity, negative 1, n plus, and minus 1, 1 over n, converges.
Where's the trash can?
I don't know, baby. Let's look for it later.
Okay, I'll find it by myself.
Yes, please. All right, questions? Good? Okay. Exactly what I said not to do. Yes, tell me. Huh? Sure. Let's do this one then. Example 2. All right, let's see this one. N equal to 1 to infinity of this guy. Divided by 4n minus 1. Okay. Convergent or divergent? That is the question. All right, so as soon as our go-to test when we see something that's alternating is the alternating series test. See if those conditions apply, and then we can do it. If not, then we have to go do something else, obviously. Okay? All right, so let's check it out. So let's see. The first condition. Is the next one less than the previous one? So let's start expanding this. Okay, if I put 1 in, that's going to give me a negative. Okay, this is going to give me a negative 3 all over, what's 4 times 1? Minus 1 is 3. So what is this? This is negative 1. Okay, then my next one, this is B1. So now B2. So this is going to be 1 times 6 divided by 7. Is that right? You guys agree? Okay, so this is B2. Oh, I can ignore the negative. I should ignore the negative because that's not the B part. I should just be looking at that. Okay. All right, so now B3, this is going to be 9 all over 12 minus, what's 12 minus 1? 11. And then B4, let's see. If I put in 4, this is going to be 12 all over 16 minus 1. 15, which is the same thing as 4/5. 4/5. This is kind of hard for me to tell which one is bigger and smaller. So I'll go to my calculator, unless you guys can tell easily, which it is getting smaller. Give me a second. 6 divided by 7 is going to, well, this is 1, and this is 0.857. 9 divided by 11 is going to give 0.818, 1, and so on and so forth. And then this one's obviously 0.8. So far, it's looking like it's getting smaller. Okay, so I think I've satisfied this condition. I might need to do a few more, but let's see. Okay, so I've satisfied that condition for the most part. So now let's check the next part. Does this, the limit as n goes to infinity, equal 0? Question mark. So let's see. Limit as n goes to infinity of my bn part. So that is going to be 3n divided by 4n minus 1. And we have done this enough times where we know if we divide by the highest degree in the denominator, or even do L'Hopital's rule. If I do L'Hopital's rule, I'm going to have, which is, right? So does this go to 0? No. Therefore, no. Cannot apply alternating series test. So, what other tests do we have? We have the P-series. Can't apply the P-series, right? We have the integral test. The integral test, can't apply it because in order for us to do the integral test, they all have to be positive, right? What else do we have? We have the test for divergence, okay? So let's try our test for divergence. Okay, so what does the test for divergence say? It says limit as n goes to infinity, an does not equal to 0 or does not exist, right? If you have this situation, then it diverges. So now I already know by looking at this. Okay, I already know, okay, well, even if this was negative, then this was positive, and this is negative, and this is positive, and so on and so forth. So let me make this negative, and positive, and negative, and positive, and so on and so forth. Okay, it's going up and down, up and down, up and down, right? It's the positives are going to converge to 0.75, and the negatives are going to converge to 0.75. But you cannot split up the positive and the negative. So in this situation, the limit does not exist. Therefore, the sum n equal to 1 to infinity of negative 1 to n of 3n all over 4n minus 1 is divergent.